So hello everyone, and today we will be seeing one of the problem from Leetcode. It says maximum product sum subarray. So the problem is simple, and it is a slight variation of one another problem. But this problem says us is we are given an integer array nums. Find a subarray that has largest product and return the product. The test cases are generated so that the answer will fit into 32-bit integer. So that is very good for us. And note that the product of an array with a single element is the value of that element. Interesting. Now we are provided with an array and the maximum product is 2 multiplied by 3, which is 6, which is the output. Now we have another number, which is example 2. Nums is, it can be -2, but again we have 0, which is greater than -2, and -1 both. So 0 is the output. So with that thing in mind, let's get started. This is very similar problem to one of the problem which we have solved, is maximum sum subarray, which follows the Kadane's algorithm. You can click the link over here, it should be popping up somewhere over here, and you can understand what the problem says. What does it mean? Cool. But what is with this? What is up with this one? How can we solve this one? Well, taking an inspiration from that is, we have went right from the start till the point where we can get the maximum number, and this is the point where we can get the maximum multiplication. Upon reaching this, we'll get -2. But now the question is, shall we reset or be optimistic? So reset means, shall we reset our counter and start from next point, which is 4, or shall we be optimistic and understand that, hey, there might be -1 in future, and let's not just reset right now, but wait. So we need to take a call. How can we take a call? Cool. But the problem is not of resetting, but the question is, if you wanted to reset again, there is one more thing. You can ask that, at what point should I reset? If I wanted to reset, then at what point? So again, if you're asking that question, you should also answer this question: at what point my multiplication is guaranteed to not go up? Like in the case of sum, where we follow the Kadane's algorithm, we are guaranteed on the point where our running sum becomes negative. But at this point, we can guarantee when our running multiplication is 0. Isn't that true? If it is 0, then I can say that no matter whatever number I multiply, so big it is or so small it is, so small in the negative sense, so big in the positive sense, it will still be 0. So this is a point of no return. Hence, reset whenever we see this. Cool. And for the rest of things, we can be optimistic. So with this thing in mind, let's get started. The problem is not yet complete, but let's see what happens if we try to do this. On surface, on upper level, it seems good. Now if we have a multiplication variable or a result, first of all I'll take a result, which initially is nums of 0, I'll say, and I'll be returning this result once I have applied some operations. Let's take some spaces. And this would be a running multiplication, which initially is 1, and I would take for a number, well, this is an index number within range of nums. I'll take one by one number, I'll multiply this number with multiplication. Now if, what I'm saying over here, if it is 0, then we have seen the point of no return, and then reset it. Multiplication is 0, then reset it, multiplication is equal to 1. And before that, but result, I need to understand, result can be maximum of result which I'm seeing currently or the multiplication. Cool, we can do this. Yeah, this helps, this works. It will run for the sample test case as well, but I have a doubt of this. What if my array is not this but this? Well, such kind of question would run for the sample test case but won't run very well for the rest of. Okay, index not used, I don't want index basically, so I'll not use it. Yeah, so such kind of questions won't run on the rest of the test cases. You see, it passes for this, but the moment I check it with one more test case having -2 in the start, and then like this, it would fail miserably, because you can guess it why. You can guess it why. We are considering -2 first. Again, as per our algorithm, -2 is first compared with rest of all, and we are assuming -2 and negative number. I mean, we are considering negative number and moving forward. So this movement is just from left to right. And do we want that? In a way, yes, we want that, but our answer was on the right hand side. So can I say not only left to right but also check for right to left? Yes, I should say that. And for that, what I'll do over here is I will create a sub method. So feel free to do this within your favorite language, whatever you like. So there would be a function which will take nums, which would be obviously integer, and this would be process, and process it. And what do I mean by process? So there would be two ways. So one would be left to right process, which would be process of normal methods, normal numbers, and there would be reverse. I'll reverse these numbers so that we could do it from right to left. So right to left process of nums, and ultimately we'll return maximum of left to right and right to left. Now this does make sense. We are not only considering left to right but also right to left, because our answer might lie on left hand sides or right hand sides. Okay, I need a return type. I have not mentioned a return type, so this is returning an int. So let's compile this one, and yeah, it has passed for rest of all the test case. There is no fourth test, and let me try to submit this one in a hope that it will run. So yeah, it has passed all of 191 test cases, and obviously this followed a very good technique of Kadane's algorithm, which internally is a part of dynamic programming. And as you can see, this comes under a topic of dynamic programming and array. For more such dynamic programming related content, click the video on your right, and I will see you in the next one.